So, good afternoon, everyone. I think in yesterday's class or day before yesterday, we have started dealing with VSAQs, and we have done with communication system, semiconductor devices, a dual nature of radiation and matter, moving charges and magnetism VSAQs. And I think we have started the magnetism and matter VSAQs. So we'll come to that magnetism and matter VSAQs later. We'll today proceed with alternating currents. We'll proceed today with alternating currents. So see here, what are the questions that will be asked in alternating currents? What is the important question that will be asked in alternating currents are? The first question is, a transformer converts a transformer converts 200 volt AC into 2000 volts AC into 2000 volts AC. Full stop. Calculate the number of turns. Calculate the number of turns. The number of turns in the secondary. Calculate the number of turns in the secondary if primary has how many turns? If primary has 10 turns. So see here, I hope you might have studied about transformer. In transformer, we'll be having transformer ratio, and there will be having one formula which is relating to primary voltage and secondary voltage and number of primary turns and secondary turns. So what is the formula for that? So I can write answer, formula. As this is the answer for 2 marks, if you are able to write the formula and answer, you'll be getting a 2 marks. So what is the formula we are supposed to write? The formula required is potential of primary turns divided by potential of secondary, that is equals to number of primary turns, or I will write capital letter, that is equals to number of primary turns divided by number of secondary turns. Number of primary turns divided by number of secondary turns. What he is given? He has given a transformer convert 200 volts to 2000 volts AC, and he is asking us to calculate what? Secondary turns. Whereas primary turns are how much? There are primary turns given is 10. So let us substitute the values. If I substitute the values, here I am supposed to find the secondary turns, so I can write this formula as number of secondary turns is equals to number of primary turns into secondary voltage divided by primary voltage. Secondary voltage divided by primary voltage. So how many number of primary turns are there? There are 10 number of primary turns into secondary voltage. How much is the secondary voltage? 2000. 2000 is the secondary voltage. And what is the primary voltage? Primary voltage is 200. So if I solve this 2 zeros and this 2 zeros get cancelled. 2 ones and 2 tens. So 10 into 10 will become how much? 100 turns. 100 turns. So the number of secondary turns are how much? The number of secondary turns are 100. This is very important question. Many times they have asked in the examination. Tomorrow I will try to show all the question papers, around 5 to 6 question papers, and you will be able to see that this question will be repeated n number of times. So I hope you are doing with me. Let us move on to the next question. So the next question is, which type of transformer is used in 6-volt bed lamp? Second one, transformer used in 6-volt bed lamp. 6-volt bed lamp. So you might have seen in your bedroom, there will be a small light. That light is called a bed lamp. So what is the voltage of this bed lamp? The voltage given is 6 volts. What will be the voltage for the tube light? It will be around 220 volts are coming to our power supply. So it will be taking some good amount of voltage. So see here, in transformer, we'll be having two types of transformer. One is called as step up transformer. What is the first transformer? One transformer is called as step up transformer. And the next transformer is called as step down transformer. So how many types of transformers we are having? We are having two types of transformers. What are those transformers? One is called as step up transformer and other one is called as step down transformer. So why we will be using step up transformer and why we will be using step down transformer means in order to increase the voltage, we'll be using step up transformer. In order to reduce the voltage, we'll be using step down transformer. So what is the voltage that we'll be getting in our house supply? That is 220 volts. But this bed lamp will take how much voltage? 6 voltage. So voltage is been reduced. So which type of transformer we'll be using here? We'll be using step down transformer. So what will be the answer? The answer will be step down transformer. So which type of transformer we'll be using? We'll be using step down transformer. I hope you are writing this. Let us move on to the next question. Third important question from alternating current. What is that? What is the phenomena? What is the phenomenon involved in working of a transformer? So what is the phenomena involved in working of a transformer? So see here, from the past three questions, we are seeing the questions regarding transformer only. Transformer used in bed lamp was how much? It was step down transformer. And third question is also related to transformer. What is the question? What is the phenomena involved in working of a transformer? Working of what? Working of a transformer. So the phenomena involved in the working of a transformer is mutual inductance. What is that? Mutual induction. So what is the phenomena involved in working of a transformer? It is mutual induction. I hope you'll remember these answers. Now let us move on to the next important question from alternating current. So what I will be writing the question here itself. The fourth question is important. Expressions for reactance of in this first question is inductor. First one is what? Inductor. And the second one is capacitor. What is the second one? Second one is capacitor. So see here, he is asking us to write down the formulas for reactance of inductor and capacitors. Very easy answer. For inductance, reactance, what we'll be writing? We'll be writing XL. What is that first one? Inductive reactance. Inductive reactance. If you want to write this inductive reactance, you can write. Otherwise, if you write directly expression, that will also fetch you the mark. It is represented by XL and the formula will be omega into L, where L is the inductance of the coil and omega is the angular frequency. What is L? L is the inductance of the coil and omega is what? Angular frequency of the coil. And what is the second one? Second one is reactive capacitance or capacitive reactance, whatever you can write. Capacitive reactance. And it is given as XC is equals to 1 by omega C. It is given as what? XC is equals to 1 by omega C. I hope you will remember this formulas. So let us move on to the next question. What is the next question that we are going to discuss? The next question which we are going to discuss is, so what was the question number? The question number was 4. And the next question that we will be discussing is question number 5. So what is that question? What is the phase difference between what is the phase difference between AC EMF and current in the following. So I am writing answer directly here. First question will be in case of pure resistor. So the phase difference between EMF and current in pure resistor will be 0 degree. Remember this. Next one I am writing pure capacitor. Circuit, actually this one is circuit. So in case of resistor, the phase difference will be 0. In case of capacitor, the phase difference will be 90 degree, or you can write pi by 2. And whereas the phase difference in case of pure inductor circuit, again it will be what? Pi by 2. In one case, current will be leading the voltage. In other case, current will be lagging the voltage. So, but you are not supposed to write all those things, but he is asking just what is the phase difference between AC, EMF and current in following circuit. First one is this circuit, pure resistor. What is the phase difference in case of pure resistor? It is 0 degree. And in case of pure capacitor, what is the phase difference? It is pi by 2. And in case of inductor, pure inductor, what is the phase difference? We are getting the phase difference as how much? Pi by 2. So let us move on to the next question. So this was question number 5. And the next question is question number 6. So what is question number 6 or means when does a LCR circuit have minimum impedance? Minimum impedance. So in LCR circuit, what we'll be having? We'll be having inductor, capacitor, and resistor. All of them will be connected in series. So he's asking what is the minimum impedance condition in case of LCR circuit. So remember that answer. At resonance, XL. What is it? The meaning of XL? Just now we have written what is XL here. XL represents inductive reactance. The value of XL will be equals to capacitive reactance. If this condition is satisfied, then we can say that the LCR circuit will have minimum impedance. If this condition is satisfied, then we can say that the LCR circuit will have which type of impedance? Minimum impedance. So when will this happen? This will happen at resonance condition. This will happen at which condition? Resonance condition. So remember this one, when XL is equals to XC, then we'll be getting which type of condition? We'll be getting minimum impedance condition for which type of circuit? For LCR circuit. So let us move on to the next question. What is the next question? I think next question is related with power factor. 7th one. The next question is question number 7. What is that question number 7? What is meant by wattless component of current? What is meant by wattless component of current. What is meant by wattless component of current? So see here, I will be discussing one term that is called as power factor. What is the formula for power factor? I hope you might have studied. The formula for power factor is given as P is equals to VI cos phi. So what is the formula for power factor? Power factor is given as product of voltage and current and cosine of angle between voltage and current. So see here, what is the meaning of wattless current means? Suppose the phase between voltage and current is how much? Let the phase between voltage and current is phi is equals to pi by 2. If I substitute that value, what is the answer I will be getting? I will be getting P is equals to V into I cos 90 degree. What is the value of cos 90 degree? The value of cos 90 will become 0. So what is the power I am getting? I am getting the power as 0 whenever the angle between voltage and current is how much? It is 90 degree. It is how much? 90 degree. So I can say that in this case, the current has no power. The current has no power. No power. Such a current is called as wattless current. Such a current is called as which type of current? Wattless current. Wattless current. I hope you are getting this. What is the formula for power? Power is given as P is equals to VI into I into cos phi, where phi is the angle between voltage and current. So whenever the angle between voltage and current is 90 degree, so what will be the power? Power will become 0. So we will be having power two components, their voltage component and current component. So as the power for current component is 0, we can say that the current is called as which type of current? We will be calling this current as wattless current. We will be calling this current as what? Wattless current. So these are the important questions. One more question is left, that is called as transformers ratio. Very small question. What is the next question? It is transformers ratio. So what is transformer ratio? The first problem we did, that is the transformer ratio. What I can write? Voltage of secondary coil divided by voltage of primary coil is equals to number of secondary turns divided by number of primary turns. This is called as what? This is called as transformers ratio. This is called as what? This is called as transformers ratio. So I hope you have got this. These are the 8 very important questions for your annual examination. So from these 8 questions, you may get one question here. So what are the questions that we have discussed? We have discussed regarding a numerical based on transformer. Next question we have discussed regarding in case of bed lamp, which type of transformer we are using? We are using step down transformer. And what is the phenomena involved in working of transformer? What are we writing? We are writing mutual induction. And what are the expressions for reactance of inductor and capacitor? Means what is the answer you are writing? For inductive reactance, the formula is XL is equals to omega L. For capacitive reactance, the formula is XC is equals to 1 by omega C. So what is the next question? The next question is phase difference between alternating current EMF and current in the following. So in case of pure resistor, the phase difference will become 0. In case of pure capacitor, the phase difference will become pi by 2. And in case of pure inductor, the phase difference will become pi by 2. So what is the final next question that we have discussed? We have discussed regarding when does a LCR circuit have minimum impedance? When does a LCR circuit have which type of impedance? Minimum impedance. So what is the condition for that one? At resonance, what will happen? Capacitive reactance will be equals to inductive reactance. And this condition is called as what? This condition is called as minimum impedance condition. So what was the next question that we have discussed? The next question that we have discussed is what is meant by wattless component of current? What is meant by what? Wattless component of current. What is the answer? I said that power is given as VI cos phi, where V is voltage and I is current. If the phase angle between V and I is 90 degree, then cos 90 will become how much? Cos 90 will become 0. So power will become 0. So the component of current which is becoming 0 is called as which type of current? It is called as wattless current. It is called as what? It is called as wattless current. So let us move on to the next chapter. That is, I think I will discuss electromagnetic waves. Electromagnetic waves. So next chapter is EM wave. EM wave. See here, what is the first question in electromagnetic waves? Important question. So what the question is, what is the principle? What is the principle for production of EM wave? Production of which waves? Electromagnetic wave. What is the principle behind production of electromagnetic wave? So see here, whenever a charge is at rest, we will be getting which type of field? We will be getting electric field. So whenever a charge is moving in a wire, we will be getting around that wire, we will be getting which type of field? We will be getting magnetic field. Whenever a charge is moving with certain velocity. But whenever a charge is accelerating, whenever a charge is, when a charge is accelerating, when a charge is accelerating, then radiations are emitted. Those radiations are called as what? EM waves. So when a charge is accelerating, electromagnetic waves, are produced. Or what? Are produced. I hope you will remember this answer. Very simple answer. When does an electromagnetic waves are produced? Mean just write down, when a charge is accelerating, electromagnetic waves are produced. Let us move on to the next question. The second question is very basic, simple question. Relation between amplitude of electric magnetic field of what? Electric and magnetic field in free space of an electromagnetic wave. So very simple, very easy answer to remember, and you will be getting 2 marks for just writing the expression. So what is the relation, sir? Means the relation is given as E naught is equal to, if I want to explain, I can write on the equation, but as we are attempting the IP answer, so if you are writing the answer, it would be more than sufficient. What is the relation given as, sir? Means amplitude of electric field is equals to amplitude of magnetic field into C. What is the relation? Amplitude of electric field is equals to amplitude of magnetic field into C. If you want to remember this, you can remember something like this. A is equals to B into C. You can remember this in this manner also. What is that? A is equals to B into C. In place of A, what you are writing? You are writing E naught. So from where we are getting this, means we are having electric field and magnetic field equation. What are those electric field and magnetic field equations? It is given as E is equals to E naught sine omega t minus kx. And what will be the magnetic field equation? B is equals to B naught sine omega t minus k x. So the ratio of E naught by B naught is equals to what? That will be called as velocity of light in free space. That will be called as what? Velocity of light in free space. So let us move on to the next question. What is the next question that we are going to discuss? Very easy question, regular life question, which you will be facing in your day-to-day life. What is that? Third one, what are the applications of microwave? Application of microwave. Very simple. If you are writing 2 points, it will be more than sufficient. If you are writing 2 points, it will be more than sufficient. What is that I can write? First application, microwave oven. Microwave oven. Why will use microwave oven? For heating the food or warming the food. Next application, microwave are used in radars. Microwave are used in what? Radars. So what our next question will be this one only. What will be our next question? Why we use microwaves in radar? Why we'll be using microwaves in radar? So where these radars will be there? Radars will be in air navigation. So let us move on to the next question. What is the fourth question? Why microwaves are used in radars. But next question, why microwaves are used in radar? So very simple answer. Why we are using this means the wavelength of microwaves is very short. We are using this because wavelength of microwaves is short. Due to which we'll be using this in aircraft navigation. So due to this condition, we'll be using this in aircraft navigation. I hope you are getting this answers. Let us move on to the next question. The next question is nothing but what are the uses of infrared rays? What are the uses for infrared rays? What is the next question number? Question number is 4. The fifth important question is uses of infrared rays. Uses of infrared rays. So what is the first use of infrared rays? The first use will be radiation therapy, IR radiation. So sometimes we'll be using infrared rays in pain management also to reduce the pain at one specific location. So IR radiation therapy. Next one, why we'll be using infrared rays? Infrared rays are used in TV remotes. These are used where? These are used in what? These are used in TV remote. So these are the applications of IR rays. What are the applications of IR rays? IR rays are used for doing radiation therapy. If you are having a pain, then you can use this radiation therapy. Next, what is the next use? IR rays are used in what? TV remotes. I hope everyone might have seen the TV remote. At the TV remote, what will be there? There will be a bulb. Have you ever seen the bulb will be glowing? No, it will actually glow, but we will not see the bulb to be glowed. Why? Because we will be able to see only visible light. So this light, these are emitting which type of rays? These are emitting infrared rays. So if you are having a remote, please open your camera, mobile phone camera, and try to press that button. You will see that the light will be blinking there. So we will not be able to see that IR rays because we will be able to see only what? Which type of rays? We will be able to see only visible rays. So I think we are done with the VSQs of. No, one more VSQ is left. We'll finish that VSQ and then this chapter will be closed. VSQs of EM waves. What is the next question? Sixth one. If wavelength of electromagnetic radiation is doubled, this question was asked in examination. if wavelength of electromagnetic radiation is doubled, then what happens to energy of photon? Then what happens to energy of photon? Then what happens to energy of photon? See here, what is the relation between energy and wavelength? We know that energy is given as E is equals to hc divided by lambda. So what is the relation between E and lambda? The relation between E and lambda is inverse relation. So I can write here E1 by E2 is equals to lambda 2 divided by lambda 1. What is telling? Wavelength of electromagnetic radiation is doubled. So lambda 2 value has become E2. Sorry, 2 lambda 1. So this will become 2 lambda 1 divided by lambda 1. This lambda 1 and this lambda 1 will get cancelled. So what will happen to the energy? Energy will become doubled. Then energy is half. So because we are determining E2 now. So I can write here E1 by E2 is equals to 2. That is nothing but I can write E2 is equals to E1 divided by 2. E2 is equals to E1 divided by 2. So what will happen if the wavelength of an electromagnetic radiation is doubled? If the wavelength of electromagnetic radiation is doubled, then the energy will be half. If you are not able to do this derivation, just write down energy is half. So if you are able to write this statement, then it will be more than sufficient. What will happen to energy when the wavelength is doubled? When the wavelength is doubled, the energy will become half. So these are the important questions from electromagnetic waves. We are done with what are the chapters we are done with today? Electromagnetic waves and alternating currents. Let us move on to the next chapter that we were discussing in yesterday's class. What was that chapter? We were discussing regarding magnetism and matter. We were discussing regarding what? We were discussing regarding magnetism and matter. See here. So we are doing the remaining questions from what? Magnetism and matter. See here. I think we have discussed one question that was regarding different types of magnetic materials, that was dia, ferro and paramagnetic substance. Based on that, I have written one formula. What was the formula? What was the trick? To remember BCD and OMP. BCD represents bismuth and copper are diamagnetic, and OMP represents what? Oxygen and manganese are paramagnetic, and nickel and cobalt was what? How much? This was ferromagnetic. So let us see the next question. The next question is second one. What is magnetic declination? Magnetic declination. I can draw the earth and I can cut the surface, the plane which will be getting, if we cut the earth surface along the geographical axis, we'll be getting geographical meridian. If we cut the axis along magnetic lines, it will be getting magnetic meridian. That angle between geographic and magnetic meridian is called as what? Magnetic declination. So directly you write the answer, no need of drawing the diagram. So what is that? Angle between magnetic meridian and geographic meridian is called as what? Is called as magnetic declination. I hope you will remember this. Don't get confused with magnetic declination and magnetic inclination. What is the statement for magnetic declination. The angle between the geographical meridian and magnetic meridian is called as what? Magnetic declination. The next question is magnetic inclination. What is third one? Magnetic inclination, or sometimes in the examination you can also ask this one as angle of dip. Angle of dip. So see here, we'll try to draw one thing. No shape, such shapes are here. Here, let me consider this to be a meridian, and we'll be having net magnetic field of Earth in this direction. Here we'll be having what? Net magnetic field. And here we'll be having which type of component? We'll be having horizontal component of magnetic field. And this is net magnetic field of the Earth. The angle between them, the angle between the net magnetic field of the Earth and horizontal component is called as what? It is called as magnetic inclination or angle of dip. So you don't need of drawing this, just write down the answer. Angle between resultant magnetic field of Earth, resultant magnetic field of Earth at a place with horizontal. Either you can write this definition or simply you can write the angle between total Earth magnetic field to the magnetic field of horizontal component of Earth magnetic field. What you can write? The angle between total Earth magnetic field and horizontal component of Earth magnetic field. Then that angle is called as what? That angle is called as magnetic inclination or angle of dip. Magnetic inclination or what? Angle of dip. So I hope you will remember this. Let us move on to the next important question from this particular chapter. That is fourth one. Magnetic lines form continuous closed loop by. What is that? Magnetic lines form continuous closed loop. The question is why? Why magnetic field lines always forms closed loop? Because if we discuss regarding electric field, electric charges, we know that from positive charge, the electric field will go outside. If we consider what? Electric charge, from positive charge, electric field will go outside. And for negative charge, the electric field will come inside. So mono charges can exist. But what is that? Separately, a positive charge can exist. Separately, a negative charge can exist. But what is the case of magnet? How many poles will be having for a magnet? We'll be having 2 poles. How many poles will be having for magnet? We'll be having 2 poles. One is called as North Pole and other one is called as what? South Pole. Can you separate North Pole and can you separate South Pole? Is this possible? This is not possible. So monopoles does not exist. Monopoles does not exist. So always the magnetic field lines will form what? They will be forming a closed loop. Okay. So this is the reason why magnetic lines form continuous closed loop. In case of electric charges, individual positive and negative charges or separated positive and negative charges can exist. Whereas in case of bar magnet, we can't separate poles. We can't separate separately North Pole. We can't take separately South Pole because all of them, both the North and South, always lies in what? They lies in pair. So this was the next question. Let us move on to the next question. That is question number 5. What is that question? Units of, I will be writing the answer directly. See, your first question he is asking is magnetic moment. Magnetic moment. Here the unit will be magnetic moment, the unit will be ampere meter square. How do you know, sir, its unit is ampere meter square? Means magnetic moment formula is given as I into A. We have already discussed this. I represents what? I represents current. What is the unit for current? The unit for current is ampere. And A represents area. What is the unit of area? Area represents meter square. I hope you will remember this. The unit for magnetic moment is what? Ampere meter square. Let us move on to the next question in this. The unit for magnetic induction. Magnetic induction. And the next question is the unit for magnetic field. Magnetic field. For both these questions, the unit will be Tesla. For both these questions, what will be the unit? The unit will be Tesla. Let us move on to the next important question from this chapter. What is the sixth one? Magnetic moment associated with solenoid. Magnetic moment associated with solenoid. Associated with what? Associated with solenoid. What is that? Just now I have written the formula for magnetic moment. What is the formula for magnetic moment? M is equals to NIA. Either you can write this answer or you can extend this one something like this. N into I into what is the area of solenoid? Solenoid will be something like this. What will be the area? Area will become pi r square. If this is the radius r, then area will become what? Area will become pi r square. Area will become what? Pi r square. So now I think we are left with only 2 questions from this chapter. Let us complete those questions and we'll move on to the next chapter tomorrow. So what was the question that we have discussed? This question was question number 6. So what is the next question? Question number 7. What do you understand by magnetization? Magnetization. So magnetization is defined as magnetic moment per unit volume. What is the definition for that one? Magnetization is defined as magnetic moment per unit volume. Per unit what? Volume. If you are able to remember this formula, then it will be more than sufficient. So what is the definition for magnetization? Magnetization means it is defined as the ratio of magnetic moment per unit volume, or it can also be called as magnetic moment per unit volume. So the last question from this chapter is, what will happen? The 8th question is, what happens to compass needle at Earth's pole? At Earth's pole. I will directly write the answer and I will explain it after that. Answer will be compass needle may align compass needle may align in any direction in any direction at Earth's pole. Earth's pole. See here, when if we consider a compass, we'll be taking only horizontal in our direction. Let us consider this to be Earth's surface. Now we know that here we'll be having north and south pole, and here we'll be having east and west. Here we'll be having what? East and west. Here we'll be having what? North pole and south pole. At this particular point, magnetic field will be perpendicular to the surface. Magnetic field will be perpendicular to this surface. So what the horizontal component of magnetic field will become? The horizontal component of magnetic field will become 0. Due to that, what will happen? The needle will oscillate in any direction. We can't say one particular direction. But in other direction, what will happen? It will dip downwards. It will dip downwards. So if you are able to write this till here, it will be more than sufficient. And we are done with the most VSAQs. And I think we are left with only the VSAQs of ray optics. We are left with what? Only the VSAQs of which type of optics? Ray optics. I will check whether we are left with other questions. But if you are able to study whatever things I have discussed till now, you will be able to score more than 55 marks out of 60. And yeah, I think we are left with only one VSAQ. Finally, if time permits, I will discuss important numericals for which chapter? Nuclear physics chapter. So I hope you understood today's class. We'll meet tomorrow. Thank you.